Okay, so let's go ahead and do a couple examples based off of what we just learned about the Pythagorean identity. So always first things first, just remember that we've learned that cosine squared theta plus sine squared theta is equal to 1. Okay, now if I ever write them in the other order, sine squared theta plus cosine squared theta, doesn't matter because it's addition happening in between, so you can flip the order and it still means the same thing. All right, so here it says find sine theta and tan of theta given that the cosine theta is equal to 2/5. Okay, so again, we're just going to go ahead and use the trig identity to solve for our sine theta. So we're given that cosine theta is equal to 2/5. So now anywhere where I see cosine theta, I'm going to replace it with 2/5, keeping in mind that this is squared. So it's going to be 2/5 squared plus sine squared theta is equal to 1. And then 2/5 squared, well, 2 squared is 4. 5 squared is 25. Plus sine squared theta is equal to 1. Then again, in order to isolate sine squared theta, first I need to eliminate my 4 over 25. So I'm going to subtract 4 over 25 from both sides. So the 4/25 cancels out here. And then already I'm just going to go ahead and rewrite the 1 as 25 over 25, just because my denominator over there is 25. And then show subtract 4 over 25. Which leaves us with 21 over 25. So sine squared theta is equal to 21 over 25. So the very last step, I'm just going to go ahead and take the square root of both sides. And that leaves me with sine of theta is equal to plus or minus the square root of 21 over the square root of 25 is 5. With the square root of 21, we can't do anything further with that. We can't even simplify that radical because 21, you just have 7 and 3. So that's where that ends there. Okay. And then for tangent of theta, as we learned from the notes previously, so we know that tangent of theta is the same thing as stating sine theta over cosine theta. Now that we've gone ahead and we've actually solved for sine of theta, we can go ahead and solve for tangent of theta since we were already given the value of cosine. Okay, so I'm going to go through and just say tangent of theta is equal to, and then sine of theta was the square root of 21 over 5. It is plus minus. I'll make sure to add that in at the end. But when we're doing our calculations, we can just use both the positive values. And then over cosine of theta that was given was 2 over 5. And then again, we can just go ahead and solve this out. The square root of 21 over 5 divided by 2 over 5. And then we can change this into a multiplication problem by taking the reciprocal of the second. So 21 over 5 times 5 over 2. And that gives us 5 square root 21 over 10, which simplifies to the square root of 21 over 2, since 5 and 10 are both multiples of 5. And then I'll go ahead and tack on that plus minus in the front. So the tangent theta is equal to plus or minus square root 21 over 2. Okay. Next problem. And let me go ahead and clear the screen from the last one. So now again, we're finding sine of theta and tangent of theta given that the cosine is 3/7. So again, using that trig identity of cosine squared theta plus sine squared theta is equal to 1. And we're given that cosine theta is equal to 3/7. So plugging that in, 3 over 7 squared plus sine squared theta is equal to 1. 3 squared is 9. 7 squared is 49. Plus sine squared theta is equal to 1. Okay. And then I'm going to go ahead and I'm going to subtract 9 over 49 from both sides. And because my denominator is 49, I'm just going to rewrite the 1 as 49 over 49. On this side, they cancel each other out. And if I subtract 9 over 49, I end up with 40 over 49. So I have sine squared theta is equal to 40 over 49, and we're almost there for this one. Of course, the last step is that we're going to take the square root of both sides. The square and the square root cancel out. I'm left with sine of theta, which is equal to the square root of 40, or plus or minus the square root of 40, over the square root of 49 is 7. And then the square root of 40 can be simplified. We can simplify that radical to be plus or minus. So 40, remember that is 4 times 10, with 4 being a perfect square. And if we take the square root of 4, that's going to give us 2. And then we still have the square root of 10 left over 7. So sine of theta is equal to 2 square root 10 over 7. Okay. Now that I know what my sine of theta is, and then I'm just going to go ahead and add to the side plus or minus. Okay. And then now I'm going to go ahead and solve again for tangent. Because remember, now that we have sine and cosine, we do have the ability to solve for the tangent of theta as well. Okay, and again, tangent of theta is equal to sine of theta over cosine theta, which again, both of these values we already know. So sine of theta is 2 square root 10. Oh no, it's fine. 2 square root 10 over 7. And then I'll just show it like this. Divided by, this is, remember, the same thing as division symbol. And then cosine of theta is 3 over 7. But again, as always, We can change this into multiplication and take the reciprocal of the second term. And when we do that, that gives us 14 square root 10 over 21. And 14 and 21 are both multiples of 7, so that becomes 2 square root 10 over 3. So tangent of theta is equal to plus or minus 2 square root 10 over 3. And then one last one. I'm going to go ahead and clear this out. For this last one, now we are finding cosine of theta and tangent of theta. Okay, so again, keeping in mind our formula, cosine squared theta plus sine squared theta is equal to 1. This time we know sine, so I'm going to leave this cosine squared theta plus 2/3 squared is equal to 1. So cosine squared theta plus 2 squared is 4, 3 squared is 9, is equal to 1. I'm going to go ahead and take away 4/9. And because my denominator here is 9, I'm going to rewrite the 1 as 9 over 9. And then the 4/9 cancel out here. I'm going to take away 4/9 over here. And that's going to leave me with 5/9. Okay. And then we have cosine squared theta oh, sorry, I'm getting a little sloppy, is equal to 5/9. And then I'm going to go ahead and take the square root of both sides. Those cancel out there. I'm left with cosine theta is equal to plus or minus the square root of 5 over the square root of 9 is 3. So now that I have cosine of theta, I can go ahead and solve for tangent. So again, tangent theta is the same thing as saying sine over cosine. Okay. And we know that sine is 2/3 divided by cosine is square root of 5 over 3. And then again, we can change that into multiplication and then just flip the second term. So 3 over square root of 5. Okay, and then here we end up getting 2 times 3, which is 6 over 3 root 5. And that is equal to 2 over the square root of 5. But just remember how we cannot have square roots in our denominator. So we're going to multiply by the square root of 5. And that's going to give us plus or minus 2 square root 5 over 5. So my tangent of theta is equal to plus or minus 2 root 5 over 5. And we will talk about later about how to know for a specific problem whether you should be using the positive or negative values of these functions. And that was the last example. Go ahead and work on the homework. And on Monday, we can talk about any questions that you all had.